Okay, so we're going to be talking about charging system diagnosis here today, and getting into just a little bit more about the charging system. Let me get this thing all squared away here. And so in the previous video, we talked about the charging system fundamentals, which was components and function, and then I gave you a little bit of a video clip on charging system parts under the hood on that 03 Toyota Tundra. So today, we're going to talk about diagnosing a charging system. So first, the common symptoms of a problem with a charging system is when we get a dead battery, where we've got slow or no cranking. And you can see in the picture, this battery's obviously got a high amount of corrosion around the positive terminal. Negative's not so bad. Battery's dirty, corrosion on the positive terminal. Battery condition is going to be the number one cause of why you have a dead battery, in addition to somebody leaving something on. But if the charging system isn't charging the car because it's a let me move this over a little bit like this. Sorry, one sec. So if the charging system isn't charging it because you got bad cable connections or something like that, you might think that's a charging system issue, and really it's not. It's really just battery maintenance. An overcharged battery, well, let me just say one other thing though. A dead battery certainly can be because the alternator's not charging the battery. And so that's why really the intention of saying dead battery causing slow or no cranking, because your battery's weak because it's not being charged properly. Second, an overcharged battery can be signaled by the fact that you've got electrolyte all over the top of the battery. I mean, you've got all kinds of white deposits on the top of the battery, and you may actually be, believe it or not, boiling the battery because it's getting too high a voltage, and that can be caused by a defective voltage regulator or a diode in the alternator that can overcharge the battery. And this is pretty rare. You don't see it very often, but headlights will be super bright, and I did see one that was holding 16 volts, and the headlights were super bright, and the battery water was coming out, was actually boiling out of the battery, and there was white deposits all over the top of the battery. And the reason why it says this can be signaled by a low battery electrolyte is because you're boiling the electrolyte out of it. You're actually causing the water to come out. Abnormal noises can be a sign of a defective alternator. A bad front bearing in particular. The rear bearing is a smaller one, doesn't carry as much load. The front one is the one that when you take an alternator like this, the front bearing, which is right behind this pulley, is getting all the force of that belt pulling down on the alternator. Okay, so that's going to cause that bearing to fail eventually. So any kind of grinding, squealing, or maybe a buzzing noise could be something inside the alternator, typically a bearing, but diodes and some other things can make noise. If your indicator light on your dash is illuminated, so your battery warning icon is on, that means that your charging system is not charging the battery. It's not a battery problem, it's a charging system problem. Or like the 03 Tundra we saw in the video, that has both a dash warning icon and the voltmeter, could be an issue there. So those are some of our symptoms: dead battery, overcharged battery, abnormal noises, charge indicator light on. Okay, so visual inspection, what do we want to look for? So the first thing we want to look for is loose battery cables. Okay, so if they haven't been tightened, I guarantee you don't have a good connection and they're not going to be charging right. Corroded terminals, like you see in this picture here, a very corroded positive terminal. So we know how to clean that with the scrub brush, and we can take baking soda and water and neutralize the acid. We can take our battery brush and clean the battery. We did all that when we did the battery service. So battery service is super important to the starting system, charging system, battery system. Okay. Low electrolyte, somebody's not kept the water full, and the low electrolyte level is going to be a cause of a battery that's not charging properly and not being charged properly. Okay, so we got to keep the water full. A discharged battery, just because we may not being charged, so we're going to go look and see what the condition of the battery is, and if the battery's got a low state of charge, then we're thinking, hey, maybe the alternator's not charging it. So a damaged battery case, This can happen. Somebody goes four-wheel driving and the battery gets pitched. A lot of times the clamps that come across the top of the battery, they rust away because of the acid, um, and they corrode away, and the consequence is that the battery can get pitched into the fan and then maybe start leaking electrolyte, and then it's not working right. The belt tension and condition. So we're going to look at the belt tension. And on a V-type belt like this, if we push in the center of the span between two pulleys, we should get no more than a 1/2 inch of deflection. So it should deflect down 1/2 inch. We measure it with our tape measure on a 12-inch span. And so if it's a 6-inch span, we only want a 1/4 inch deflection. On the serpentine belts, if it has a serpentine belt, we have gauges to measure the depth of that. And I think I'll remind you of that and pause the video and go grab one to show you. Okay, so I've got a serpentine belt here. This one's obviously in really bad shape. You can see the cracks and so on. The correct way to check this is to take one of these gauges and you lay this into there, and you're supposed to be able to see, if you turn it like that, see the orange gauge or feel it. If it's flush like this one is or recessed, the belt grooves are worn by the pulley and this belt needs to be replaced. Okay, so first, here's a serpentine belt that's obviously really cracked, and you can see all the cracks. You can see chunks missing out of it. So the Gates company that makes belts and hoses has these gauges. I'm going to show you two different styles. Here's one, and when you put this in the groove of the belt like that, and you turn it sideways, you're supposed to be able to see the gauge. And if you can't see it, that means the grooves are worn by the belt to the place that it's sinking too far in there, so this belt needs to be replaced. They also have another style of gauge that just has these two little plastic ribs, and if I put this into a brand new belt so you can see it hopefully, and put it into the grooves there, and you're not supposed to be able to wiggle this around. Here's a worn belt. That was a new belt. Here's a worn belt, and when let me get my thing untangled here so I can do this properly. Okay, so here's a worn belt like this, and when I put that one in there, now I can move this guy all around, so I know this belt is worn out. So the pulley grooves will eat, or the pulley teeth, so to speak, will eat into the belt, and that's what causes them to go bad. Let's continue along here. So next is wire condition. So we can look at the wiring harness and the wires underneath the dash and see if a rat's been eating on them or they've corroded away or some kind of thing that happens so we don't have a good connection somewhere. Here's a picture of an old school belt tension, or just showing belt tension. It says take moderate thumb pressure in the center of the span, and you're supposed to have no more than 1/2 inch of deflection, that is the belt being pushed down, so like this, right, for a 12-inch span. So if there's a 6-inch span from pulley to pulley, you should only deflect a 1/4 inch. Okay, so 1/2 inch deflection is maximum for a 12-inch span. And these are just showing some different types of belt problems, showing that some cracking is considered normal, and that's okay. When they get weird cracks like this, you want to replace it, or any of these type of conditions where the belts are starting to disintegrate from oil or debris or being burned, we want to replace them. I will say this, even though they say some cracking is normal, what I usually find is when the belts are cracked like that, they're super dry and they tend to be noisy and squeaky. So we like to replace them to get a nice soft rubber belt so it wants to ride smoothly and not make so much noise. Okay. This is just showing you how to adjust a belt. This is a V-type belt, I believe, and it's got a lock nut, and we're going to loosen the lock nut, then pry the alternator out and tension that belt and then tighten it up. More modern cars, everything is, as you guys remember, is spring-loaded. So we've got spring-loaded tensioner on the belts. And most Hondas and Toyotas don't do this anymore. This was kind of an American car thing. They will have a tensioner device where you loosen a lock nut and you turn another bolt, and that puts tension on the belt. So a couple of charging system precautions. We'll talk about these next. So let's look at these charging system precautions. So anytime you're working on the charging system or anything electrical, we want to disconnect the battery before we service. And that means we're going to disconnect the negative cable. That's all we need to disconnect. Once that negative cable is disconnected, everything is shut down. No possible problem of short-circuiting something. Remember, you can't get electrocuted by a battery or an alternator, but you can get burned by the high heat of high current discharge. You never want to reverse polarity. That means you don't want to switch the cables to the wrong side. Now, that's really important. You'll definitely pop a bunch of fuses. If you hook up jumper cables wrong or a jumper pack wrong, you're going to damage some fuses and maybe a computer module, but most times just fuses. But still, you don't want to do it because it's a hassle to figure out. We're not going to operate the alternator with the output disconnected. That was something that we used to do old school, but you definitely don't want to do that now because you can fry wires and you can also hurt a control module or computer. So there is a thing called an alternator output test that measures the system current and voltage under maximum load. It's not something we do in this class, but I just want you to know that there is a way of looking really effectively at, does the alternator produce the current and voltage that it's supposed to under maximum load? This test is becoming somewhat antiquated because modern cars don't want to let you do this, but they will have you do things like turn on certain accessories and then measure how much current is actually coming out of the alternator to decide if the alternator is doing its job. Again, this is like when we did a battery and we said it was like stress testing the battery, like putting you on a treadmill. Same kind of thing. We're stressing the alternator and seeing what it will do with this alternator output test. But in the charging system fundamentals video that I did, and I showed you the voltmeter and on the dash, and I showed you the voltmeter under the hood, you saw that the charging system was charging at approximately 14.08 volts. And that told us that the charging system is probably working. This one's going to actually stress the alternator and see what it's capable of doing. We use a load tester with what's called a voltmeter and an ammeter. This is an old school analog one. We have digital ones now for this. Okay. Here's the equipment connections, just how you hook it up, but you don't need to worry about this or take any notes here. The machines in the shop, when you do this, I have the instructions posted on the machine so you can see. But basically what we're going to do is we're going to start the car and we're going to crank up the load and try and suck current out of the battery, and the alternator is going to try and backfill. And so what we're going to see is the current here to this inductive amps connector. We're going to see how much current the alternator is actually charging the battery with. It just tells us that we start the engine, take it to 2,000 RPM, and we're going to load the charging system up until it drops down to 12 volts, and we're just going to read the amperage output. Again, you don't need to take notes on this. I'm just exposing you to the idea of a charging system output test, alternator output test. Okay, that's it. Thanks so much.